All right, good morning. The other day we were looking into functions and domain as well as looking at functional values and expressions. And for what we have regarding the most recent assignment I have given out, okay, and that is for starters from page 147. Now we're looking at the determination of function value, and we have in number 44, okay, we have a function f of x, okay, which is given as a quadratic function where we have it set equal to x squared plus 3x. Now we're looking at finding out, okay, what f of 5 is going to be. And again, f of x is another way of saying what we have for y and the xy coordinate system. So we're looking at what the y value is going to be whenever x is equal to 5. So for f of 5, okay, upon substituting that value for x, and we have in the follow through, okay, we have f of 5 is equal to 5 squared plus 3 times 5. And we have, in the case of the follow through, okay, so we have 5 squared is 25. And we have plus 3 times 5. 3 times 5 is 15. And we have for the result here, so on the graph of this particular function, we have that whenever x is 5, well, we have that the y value will come out to 40. All right, and we have also in the mix, and we have in reference to numbers 47 and 56, okay, we have a given function whereupon we have g of x is equal to the reciprocal of x. And for number 47, this might be the easiest problem within the whole book, where we're looking at just g of t, okay, and in the case of the input at t, well, the only thing you're going to do here is to replace x with t. So g of t we have right away at 1 over t. And for what we have in the case of number 56, okay, we now have g of x plus h. So just change the input x to the binomial x plus h. Again, whatever the input is, we're going to take the reciprocal. So we have for g of x plus h, okay, this will come out to 1 over x plus h. Right. Now, crossing over into the threshold of determining domain of given functions, and in number 100, okay, now we have different letters in the mix. And in the case of 100, now we have not y of x, but y of t. And okay, so for y of t, now t is the independent variable, y is the dependent variable, and this function is given as a radical, where we have the square root of 16 minus t. And in looking at the domain of this function, okay, so we're focusing upon what t can be. And since we're starting out with an even root radical, okay, again, we're looking not at the complex number system, just the real number system. So for the square root of 16 minus t to be real, okay, whatever we have in an even root radical cannot be negative. So we have in the setup, so we have 16 minus t cannot be negative. And in creating a pathway forward, okay, we can set up what we have for 16 minus t as a comparison to 0 inequality. Now, we can have 16 minus t to be 0 or positive. And so setting up what we have here, okay, we can start out looking at what we can find out for t. And it'll be those values of t where 16 minus t is greater than or equal to 0. And if we look at isolating the variable term, and we're going to have upon taking 16 away from both sides, okay, we're going to have on the left, okay, we're going to have negative t is greater than or equal to negative 16. And again, we're solving for t. So changing the sign at both ends. I can either multiply or divide by a negative. And again, just remember, if you multiply or divide by a negative, we're going to have the direction of the inequality to change. So here we're going from greater than or equal to less than or equal to. So we have for this outcome, left hand side we have t, and t is going to be less than or equal to 16. And expressing the domain in interval notation. Okay, so we have conceptually, okay, so we have with t less than or equal to 16, and if I were to graph, okay, have part of it, we have t equal to 16, so 16 is going to be with a solid point on it, and everything else is going to be less than, so we're going to have a ray that is going to go out to the left, and we have going continuously in the direction of negative infinity. Alright, so again, just the graphing part is optional, but it does provide a little bit of a visual in terms of how to set up the interval notation for the domain. And so here we are going, as you read in order from left to right, negative infinity, which will be in the parenthesis, again due to infinities, positive and negative, being boundless. And we have approaching and including 16. And 16 is going to be in the bracket. Right. And so that is going to be the result for what we have in part A of number 100. Now, for what we have in the case of part B, and we have this time we're going from y of t to w of t. And here we have w of t is equal to yet another radical, and still working with the variable t. So we have the square root of t minus 16. Once again, because we have a square root, t minus 16 cannot be negative. And so we're going to once again set up a comparison to 0 inequality. Okay, so it can't be negative. So in other words, t minus 16 cannot be less than 0. It can be 0 and it can be positive. So just as I had done with 16 minus t in part A, I'm going to set t minus 16 greater than or equal to 0. And looking at isolating the t. So this time I'm going to add 16 to both sides. And so we're going to have t is greater than or equal to 16. And just supplying the visual on this. Okay, so again we have 16 as the focal point, and thanks to the inclusion of 16 from t is greater than or equal to 16, okay, we have a solid point. And then we have with the activity, we're going to have a ray that is going to go out to the right, and we have tending toward infinity. And so for what we have in the case of the domain, okay, notice that the lower limit is at 16, whereas before 16 was the upper limit. So we're going from and including 16. And the interval notation has this in the brackets. And again, the upper limit we have going to infinity, okay, which runs endlessly. And now, for what we have in the case of part C, we have a little bit of a twofold situation. So I'm going from y of t to w of t to now z of t. And for z of t, okay, this is equal to 1 over the square root of 16 minus t. And there's a bit of a dual situation that is occurring. Now again, we have Like from part A, you have 16 minus t within the square root. So again, we have 16 minus t cannot be negative. And now looking at the location, okay, now 16 minus t, not only is it in the square root, but it is also in the denominator of this particular function. So that means that for a radical to be defined in the square root, okay, you cannot have the expression to be negative, and for a fraction, the denominator cannot be 0. So we have 16 minus t, not only can it not be negative, but it also cannot be 0. So that means that 16 minus t can't be negative, can't be 0. So that means that in terms of any category that 16 minus t can be, well, to get the entire domain for this function, okay, we must have it where 16 minus t is going to be positive. Okay, so out of your categories, if it can't be 0, can't be negative, well, the only remaining category is for 16 minus t to be positive. And so as an inequality, we'll have 16 minus t is greater than 0. Remember, cannot be equal to 0. And in taking what we have and solving for t, once again, like in part A, I'm going to move the 16 over by subtracting. And we're going to have negative t is greater than negative 16. And partial history repeating. So if I change the signs at both ends so as to convert from negative to positive t. Okay, so multiplying or dividing by negative, okay, forces the inequality direction to change. And we have on the left, okay, we have t is less than positive 16. So just looking at it from a visual standpoint. So we have for t is less than 16. Yes, we're back to focusing on 16. Now 16 is not included, so we're going to have a whole to indicate that 16 is not in the mix. And then we have representing t. Okay, so we have array going to the left. We have going endlessly in the direction of negative infinity. So for the domain, and expressing as an interval, okay, so we have going from negative infinity, and we have approaching but not including 16, and the 16 is going to be in the parenthesis. All right, so that's going to be the domain for what we have in number 100, part C. Now, for what we have in the case 104, okay, and I'll tell you what, we'll look at all these particular parts here, and for number 104, okay, now we have first function, okay, we have that r of x is equal to x squared minus 4x minus 12. Okay, and if you notice, we do not have a fraction, we do not have an even root radical, and there's nothing to indicate that x cannot be 0 or positive or negative. So if we plug in anything for x from the real number system, you're going to have a defined value for r. So for this particular function, okay, we have no restrictions. So we have no restrictions on x. So that means that we have, in consequence, okay, x can be anything from the real number system, and the domain is going to be the set of all real numbers. Once again, the interval notation for the set of all real numbers will be parentheses going exclusively around negative and positive infinity. And we have for the next item, okay, we have going from r of x to s of x. And for this particular function, okay, this is set equal to x squared minus 4x minus 12 all over x plus 1. Now for this particular function, okay, we have a fraction. Again, there will be a restriction whereupon we cannot have a zero denominator. Okay, so we have the x plus 1 cannot be equal to 0. So we have, in effect, if x plus 1 cannot be 0, this signals that x cannot be negative 1. And this is going to be the only restricted value we have for x for the function s of x. And to give you a bit of a visual so as to be able to express the domain in interval notation. Okay. So we have, this time we have the value to focus upon to be at negative 1. So we have negative 1 is excluded. So you're going to have a whole at negative 1. And everything else is going to be in the domain. So you have those values that would be less than negative 1. Now, so you're going to have those values of x greater than negative 1. Okay, so you have going in opposite direction. We have left ray, we have pointing out continuously to negative infinity, and the ray pointing to the right, we have going continuously out toward infinity. And so we have for the domain, okay, so you have going from negative infinity, approaching but not including negative 1. Negative 1 is going to be in the parenthesis. Okay, so this will be for those values of x less than negative 1. And we have, for the domain, you have in union with those values of x that will be greater than negative 1. And that is indicated by the ray going out to the right. And just the symbolic interval notation, we have parentheses around negative 1 and positive infinity. Okay, so the domain of s of x will consist of two subinterval sections. Okay, those less than negative 1 and those values of x greater than negative 1. Now, in the case of what we have with part C, okay, we have the function t of x is equal to x plus 1 all over x squared minus 4x minus 12 okay, so you have an inverse relationship, as in a reciprocal relationship between s of x and t of x. Okay, so this time around, now before with s of x, x plus 1 could not be 0. Now for t of x, it is now the trinomial that cannot be 0. So we have with t of x, again, x squared minus 4x minus 12 cannot be 0. And if the whole expression cannot be 0, then neither can its factors. Okay, so for the factors of the trinomial, okay, we're going to have x plus 2 and x minus 6. And looking for the exclusions. Okay, so you have itemizing the factors and finding out what in x cannot cause x plus 2 to be 0 or x minus 6 to be 0. We have for x plus 2, if this cannot be 0, then x cannot be negative 2. And if x minus 6 cannot be 0, we have that x cannot be equal to 6. And so we have, in terms of drawing up, okay, what we're going to have in the domain. So we have, again, we have with the exclusions, we have negative 2, positive 6, And again, on -2 and 6, okay, we have just representing their exclusions, we have holes. And as for what we're going to have included in the domain, so you have those values between but not including -2 and 6. And we have at the extreme opposite ends, we have those values x less than -2, as well as those values of x that will be greater than 6. Okay, and so we have for the whole packaging, and reading in order from left to right. Okay, so we have for the activity around the whole at -2, so we have preceding this, okay, we have going from negative infinity, approaching but not including -2. And then we have next section, we have bypassing -2, approaching but not including 6. And then we have working around 6, we have going past 6 and not including 6. And we have going continuously out to infinity. All right. And if you notice in part B, we had one exclusion from the real number system. So we had 2 subintervals formed. And in the case of part C, we had not 1 but 2 exclusions. And guess what? We had the formation of 3 subintervals in the domain. And if I had yet like 3 exclusions, guess what? You would have kind of a long domain interval listing where you would end up with 4 subintervals. All right. And okay, so time and again, we will be focusing upon domain because we're going to be kind of stuck with the functions pretty much from here on out. And now, looking at the pathway forward, okay, in working with functions and equations. Again, we had looked into briefly the other day, okay, the topic of slope. And we have just going into page 162. And again, we have regarding slope. And it is from the concept of slope that we're going to have a variety of equations in the mix. And in the case of 28, okay, we're looking at trying to find out, okay, what the slope of the line will be whenever it passes through, that is, whenever the line passes through -9, 4, and -1, -6. And again, we have with the slope formula. Again, we're looking at change in y with respect to change in x. And the most common general notation, or at least in recent history, have y2 minus y1 all over x2 minus x01. And we can go ahead and identify what those x and y values will be. Keep in mind that all ordered pairs are of the form xy. And we'll let -9, 4 be the first set. So we have -9 to be x01, 4, y01. And we have with the other ordered pair, -1, we have x02. And -6, we have y02. So before you start working with this formula, go ahead and lay out, okay, what the subscript to x and y terms are going to be. And so, having identified, and we can plug in now for y2 minus y01. Again, y2 we have at -6. And we have minus y01, so we have -4. And for x02, we have -1 minus x01, so we have -9. And we have in following through, okay, so we have -6 minus 4, so we have -10. -1 minus -9, we have -1 plus 9. So we're going to have -10 eighths. And this ratio can be simplified since we have even numbers in the numerator and denominator. So this will go all the way down to -5/4. And so that's going to be your slope. So this would be kind of like a pattern of where you're going down 5 units and then shifting over to the right 4 units. Now, for what we have also in the determination of slope, we have for number 33, okay, we have a couple of ordered pairs, and we have non-integer values in the mix. So we have first order pair mentioned, we have 3/4 and 6. And the other one we have 5/2 and 1. And again, if we go ahead and identify the x and the y values. Now, you could let 5/2 and 1 be the first set, 3/4, 6 be the second. It would still be the same slope. But I'm just going to label it in the order that the numbers appear. And so we have for the slope, okay, so for the change in y, we have for y2 minus y1, so we have y2 at 1 minus y1, so we have minus 6. For x2, we have 5/2 minus x01, so we have the subtraction of 3/4. Right, so we have a bit of a complex fraction here. Not as in complex numbers, but where you have like a ratio where we have at least a fraction in the numerator or denominator. And here we have 1 minus 6 is -5. Now for 5/2 minus 3/4, to be able to combine these two terms, I can rewrite 5/2 in terms of fourths. Again, 5/2 will be 10/4. And we have, again, in the numerator, so have -5. 10/4 minus 3/4 becomes 7/4. And to get out of the complex fraction notation, if I divide by a fraction, it'll be the same as multiplying by the fraction's reciprocal. So we have like -5 times, and then division by 7/4 translates to multiplication by 4/7. So we have for the slope here, we got, think of it like -5/1 times 4/7. In this case, this will come out to -27. Okay, so we're going to have yet another negative slope in this one. Okay, now for what we have looking at the determination of slope, say from provided graphs, in the case of number 39, okay, so we have a downward sloping line as the line moves from left to right, and just kind of depicting what we have. So we'll put in x-axis as well as a y-axis. And okay, now we have, okay, from your book, okay, you can pick out a couple of points. It looks like we have, okay, so you have on the y-axis, you have location of the line on 0, 2, and say you have also in the system, okay, we have, if you look at the grid pattern, okay, the line is going to run through the ordered pair 3, 1. Okay, so what we can do here, okay, is that we can let 0, 2 represent x1, y1, and have 3, 1 to be the second ordered pair. And so in the case of the slope, So y2 minus y1 all over x02 minus x01. Again, for the change in y, okay, so looking at what we have designated, so y2 minus y1, we'll have 1 minus 2. And for x02 minus x01, we have 3 minus 0. And we have 1 minus 2 is negative 1, 3 minus 0 is 3. And so we have, on the basis of taking what we have with the slope formula, okay, this will come out to negative 1/3. Okay, but also you can have, just looking at it visually, you can have a bit of triangular formation and just sort of extending out. And so there's just going to be a pattern. So as you go from 0,2 to 3,1, okay, you have just with the triangular formation, say if you have go down 1 and shift over 3 units. Yeah, move over to the right 3 units, and you're going to have, in effect, okay, so you have going down 1 unit and over to the right 3 units, and this is going to signal that the slope is still going to be minus 1 over 3, or again negative 1/3. All right. Now, in the case of what we have for 42, and this is one where we're going to have the line to have the x value fixed throughout. All right, so we're going to have, in this case we have a line, okay, so you have between 1 and 2. So you have a line continuously running up and down. And we can just pick some points. Okay, we have something like three have 0. As well as 3 halves and 1. Okay, so we have in the labeling. So you have for the slope, you have y2 minus y1 all over x02 minus x01. For y2 minus y1, again we have 0 minus 1. For x02 minus x01, guess what? We have the same x values. And I had mentioned the other day that for the slope to be defined, you cannot have the same x values. So if you notice, we have negative 1, 0. And so creating the situation of trying to divide by 0, okay, the slope ends up being undefined. And again, that just reaffirms, okay, that the line is vertical. Now, tied into what we have with slope, again, there are going to be variations of equations that are going to be within the xy coordinate system. And we have among the variations, okay, we have starting out, and this version is going to be linked with yet another equation. And the first, or the introduction, okay, we have in the form of what is referred to as the point-slope form of a linear equation. Okay, and just for what we have in the case, the point-slope form of a linear equation. So you have the point-slope equation of a line that's going to have a slope m, and that passes through a point. And we'll just designate the coordinates as x01, y01. It's going to be, and we have with this equation, now we normally say x before we do y, but in the point-slope equation, we're going to have y expression, the y expression at the front. So we're going to have y minus y01 is equal to the slope m times the quantity of x minus x01. So that is going to be the point-slope equation. Now, for what we have in the case of the variable y, the y that is out at the front, and isolating y is going to lead to what is referred to as the slope-intercept form of a linear equation. And there'll be a little change up in the variables, but from this we're going to have y isolated, and we have symbolically, okay, for the slope-intercept form of a linear equation, okay, this is going to come out to y is equal to mx plus b. Okay, so we have with the characters, okay, so m is still going to be the slope, and the b, okay, that's just going to be what will be regarded as the y-coordinate of the y-intercept. So whenever you hear slope-intercept, slope is in reference to m, whatever is next to x. Intercept, we're looking at y-intercept. And it seems to be the pattern that the book is going to stress the y-intercept in coordinate terms. where we have 0b, whereas in Alex, okay, it will just stress like the y equals. In other words, y is equal to b. And we have, in the case of, what we have regarding point slope and slope intercept equations. And let's say that if you were to have if you were to determine the slope intercept equation, let's say we have given, okay, first of all, okay, we have, let's say that the slope is provided, and say we have is equal to 5, and the point through which the line passes, okay, we have a -1, -2. Okay, so kind of creating the way forward, okay, to getting to y is equal to mx plus b. Again, we're going to start out with the point slope formula. Okay, so again, so you have y minus y01 is equal to the slope m times the quantity of x minus x01. And if we take direct substitution with y minus y01, we have y minus -2 equals m, which is at 5, times the quantity of x minus x01, which is -1. And cleaning up the subtraction of negatives, we have y plus 2 is equal to 5 times the quantity of x plus 1. So for what I have right now in this formation, okay, this is going to be the point slope equation. Again, I'm looking for the slope intercept equation. Now the point slope equation is going to be the backdrop to determining the slope intercept equation. So as I proceed forward, we have y plus 2, and distributing 5 over the binomial x plus 1, we have 5x plus 5. And isolating y, we subtract 2. And so we're going to have y is equal to 5x plus 3. So we have in this particular format, okay, again, whatever's next to x is going to be the slope. Okay, so here we have the slope intercept equation. And again, we had the slope m is equal to 5. And that 3, the 3 is going to be the letter in reference to the letter B. So you have for the y-intercept, you're going to have 0, 3. We're also putting it in terms of y equals, we have that y is equal to 3. All right, another instance, say where we have the slope provided, okay, and this will be, say in this case, we'll have a negative value, so we have a -4, and we'll say that for the point through which this line passes, we'll have this at 2, 6. Right. So starting out with the point slope equation. Okay, so we have y minus y1, so we're going to have y minus 6 is equal to m. Now m is at negative 4. And we have times the quantity of x minus x01. We have x01 at 2. And so we have, upon substitution, okay, so y minus 6 is equal to negative 4 times the quantity of x minus 2. That's going to be the point slope equation. Now, in looking for the slope-intercept equation, so y minus 6 is equal to negative 4x plus 8. And in isolating y, we have upon adding 6 to both sides, we're going to have that y is equal to minus 4x plus 14, and this outcome is going to be the slope-intercept equation. And this time around, we're going to have that the slope is equal to negative 4, as already stated. And for the y-intercept, now your b value is going to be at 14. In coordinate terms, now we're going to have 0, 14. Or putting it in equality terms, we have y is equal to 14. Alright, and just want to mention, now there'll be a case where we don't have the slope provided, but I just want to mention upon checking for the consistency. Okay, so you had the slope at 5. Now if we designate negative 1, negative 2 respectively for x and y, left hand side of the equation we have at negative 2, and if it is consistent, that is, if the slope-intercept equation is consistent, both sides of the equation will be equal. So with this point, y is at negative 2, and with x at negative 1, you have 5 times negative 1 is negative 5, negative 5 plus 3 is negative 2, negative 2 is equal to negative 2, so this checks out. Now with 2, 6 for x and y, now y is at 6, and we have with x at 2, negative 4 times 2 is negative 8, negative 8 plus 14 is 6, left hand side is 6, right hand side is 6, 6 is equal to 6, and so this equation also checks out. Now, if we have a case where the line runs through and we'll say that we have with our order pairs, we have 0, 6 and 2, 12. Okay, so instead of having the slope given at one point, we have 2 points provided. So that means that, okay, if we have a line running through these points, okay, we have to determine the slope. Okay, so to find out, okay, just what the slope is going to be. Again, just going back to the slope formula. Okay, so we can go ahead and identify our first and second x and y values. So let 0, 6 be the first set, and 2, 12 be the second set. So we have for y of 2 minus y of 1. Okay, so we have y of 2 at 12, y of 1 at 6. So we're going to have 12 minus 6. Now for x02 minus x01, we're going to have 2 minus 0. And 12 minus 6 is 6. 2 minus 0 is 2. And 6 divided by 2 is equal to 3. So we now have the slope at 3. And in terms of what to do now in the point slope equation setup, you can choose either ordered pair. In other words, now we have the slope. You can choose either order pair to represent the x1, y1 and the point slope equation setup. And we'll go with 0, 6 on this one. And again, you have your slope value at 3. And so just doing a little bit of color coding here. So you have y minus y1 is equal to the slope m times the quantity of x minus x01. Okay, so you got y minus y01. So again, your y01, if I choose 0, 6, okay, your y1 is going to be at 6. We have equal to the slope m, which we have at 3. And we have times the quantity of x minus x01, which we have at 0. Again, this is going to be your point slope equation. And we have in the follow through. Okay, so you have y minus 6. And 3 times x minus 0. Well, that's just going to be 3x. And looking at the isolation of y, as we add 6 to both sides, so we're going to have that y is equal to 3x plus 6. And that would be the outcome in this one. Okay, so we had the slope is going to be at 3, and guess what? Your b value is at 6, and your y-intercept we have at 0, 6, and that was one of our 2 given points in this setup. And now you can check for the consistency. So if we have x at 0 and y at 6, so we have 6, and then we have 3 times 0 plus 6. Guess what? Left hand side is 6, right hand side is also at 6. Now for 2, 12, if y is at 12 while x is at 2, well, we got 3 times 2 is 6, 6 plus 6 is 12, and that is what we have for y in this second point. So that is also going to check out consistently. And now, just looking at what we have concerning what we have in looking at what is present in the case of the slope intercept equations. And we have again, just kind of going back to the set, we have on page 162, okay, so we have on page 162. Okay, so if we're looking at the slope-intercept equation, so we have from number 52, okay, and we have, this time we have an equation in x and y, whereupon we have 3x minus y is equal to 6. So this is a standard form of the equation we have for x and y. And I want to express this in terms of y is equal to mx plus b. So I have a bit of work to do. First of all, I want to get the y term by itself. Right now we have the term at negative y. And so if I move the 3x over, so I'm going to subtract on both sides here. So I'm going to have that negative y is equal to negative 3x plus 6. And again, if I change the signs at both ends, so if I multiply or divide by negative 1, you'll just have the sign change throughout. What was negative will become positive and vice versa. And so we have, in this case, we're going to have that y is equal to 3x minus 6 and in terms of identifying, okay, the slope and the y-intercept, so again, we have whatever's next to x in this format is going to be the slope. And as for the negative 6, okay, this is going to signal that the y-intercept, we can write as either 0, negative 6, or y equals negative 6. And just looking at what we have in terms of illustrating. So we have, in the case of a graphing setup, okay, so you have in the cycle, again, I'm just going to sketch this, not quite draw it out completely, but for the activity, okay, so you have a y-intercept of 0, negative 6, okay, and you're going to have a pattern, okay, so the slope at 3, so there's going to be a cycle of going up 3 units, and a shift of 1 unit to the right. So you have a bit of a triangular formation, so you have like going up 3 units and out to the right 1 unit. Kind of like a staircase pattern. Again, up 3 units and out to the right 1 unit. And so you have like among your ordered pairs, you have 2, 0, 1, negative 3. And 0, negative 6. Okay, and so for the line going through, okay, this will represent all the combinations of what we have in x and y for this given line. So you have 0, negative 6, and again 1, negative 3, as well as the x-intercept 2, 0 will be among other among infinite points through which the line is going to pass. Now, for what we have in the case of an equation that is given, whereupon we have x and y terms together, but also where the fractions are also in the mix as the coefficients of the variable terms. So we have in 62, say we have x over 3 plus y over 4 is equal to 1. And again, the object is going to be to write this equation in the form of y is equal to mx plus b. And what I can do is just, I can get out of the fraction mode, and here the least common denominator, okay, it's going to be the smallest value that both 3 and 4 will go into, so that is going to be at 12. And we have looking at distributing 12 over these terms. Okay, so for what we have in the mix, we have for 12 times x over 3. Okay, we have 3 will go into 12 4 times. I'll just copy this. Okay, so we have in the mix, so we have 3 will go into 12 4 times. 4 will go into 12 3 times. So we have in the rewrite, okay, we're going to have our standard form adjusted to 4x plus 3y is equal to 12. And then we have in isolating the y term. So if I take 4x away from both sides, so we have 3y is equal to negative 4x plus 12. And we have with division by 3. So we're going to have that y is equal to negative 4/3 of x plus 4. And so we have with the components. Okay, so you had the slope m is equal to negative 4/3. So there's going to be a pattern. Say if you read in order from left to right, so you have like going down 4 units and to the right 3 units. Again, we have for the y-intercept. So we have 0 4. Or y is equal to 4. And in terms of the kind of a trend that'll be created, okay, with this slope-intercept equation, and once again just setting up the x-axis as well as the y-axis. Okay, so you have your y-intercept is 0 4. Okay, so for what we're going to have here, so we're starting out at 0 4. And the trend is going to be going down 4 units and shifting over to the right 3 units. So we go down 1 2 3 4 and shift over 3 units. Then we have another order pair at 3 0, and if we go down another 4 units and shift over 3 units, and we come out to 6 negative 4. And so connecting the dots, okay, this will we have a line that's going to represent all the combinations of x and y that will belong to any variation of x over 3 plus y over 4 is equal to 1, including that slope-intercept equation. All right, and now for what we have in this case, now the variations of the equations, the point-slope equation as well as the slope-intercept form, okay, we've looked at those in the capacity of single lines, but if I were to cross over in the case where you might have two or more lines and looking at the relation, and so we're going to have for cases involved, if you have two or more lines and seeing how they're going to relate in terms of the motion. And what I mean by this is that we have just adding categories. This will be for what we have with parallel and perpendicular lines. And for the categories now for parallel lines. Parallel lines, okay, those are going to be distinct lines. Distinct as in they're not the same. But they're going to have the same kind of behavior motion-wise. They're going to have the exact same slope. And will thus never intersect. And just kind of give you a couple of cases here of lines that run parallel to each other. See, we have like y is equal to 4x plus 3, as well as y is equal to 4x minus 7. Okay, notice, okay, both of these lines, okay, and this is just a little bit for convenience purposes. They're provided in slope-intercept form. Okay, and notice, okay, the lines are different because we have different y-intercepts. But now, for what we have in the pair, we've got the same slope, which in this case we have m is equal to 4. Lines are different from each other, and so we have the lines are going to be parallel. And just shorthand for this will look sort of like a sideways 11. So the lines here are parallel, and we have likewise, if we have, say, y is equal to negative 7/2 of x, and say we have y is equal to negative 7/2 of x plus 9. Again, we have the same slope. At negative 7/2. And because it had the same slope, the lines are also going to be parallel. All right. Now, in the case of perpendicular lines, okay, we have a bit of a different story with this relation. for perpendicular lines. Okay, now you're going to have these lines. You will have lines that will meet at a 90-degree angle. Or if you're taking geometry, okay, that's also referred to as a right angle. And in terms of how they're able to meet at a right angle or 90-degree angle, that would be because these lines will be opposite sign reciprocals. In other words, if they're opposite sign reciprocals, you're going to have the product of their slopes to end up at -1. And just taking cases again for what will be the formation of perpendicular lines. Okay, so if I have y is equal to 4x plus 3, and now I'll be looking for, let's say if I have some value times x minus 7. Now before, when I had the coefficient 4, we had the lines to be parallel. But now you're going to have, in the case of the lines here, I want to draw up for this coefficient the opposite sign reciprocal of 4. So I'm going from a positive to a negative. And the reciprocal of 4 is going to be 1/4. So guess what? Opposite sign reciprocal of 4 is going to be -1/4. It's going to have like first slope times the second slope. We're looking at 4 times -1/4. So this will be -4/4. And so that will be equal to -1. Okay. And since the product of the slopes is going to be -1, so we have that the lines are thus going to be perpendicular. And that can be sort of symbolized by what looks like an upside down T. Also tied in, see we have y is equal to -7/2 of x. Okay, now for this particular second line to run perpendicular to y is equal to -7/2 of x, I need the slope to be the opposite sign reciprocal of -7/2. So we can go from a negative to a positive, and then we have the reciprocal of -7/2 is going to be 2/7. So we have the product of the slopes. So we have -7/2 times 2/7. And I can do cross multiplying, or I can just multiply across throughout. So you have the negative of 14 over 14, and that goes to -1. And once again, these lines are going to run perpendicular as well. And so we're going to be looking into cases involving parallel and perpendicular lines, and just some items to mention. Okay, so the Alex homework section 1.3 is due Saturday night. Okay, section 1.5 will be due Monday evening. And again, I do have video simulations, and and the crossover to parallel and perpendicular lines. Okay, so you have on page 176, number 6, 12, 23, 26, 37, and 39. And I've been asked, okay, about like availability of like the virtual office hours, and I'm going to have that through Zoom. Okay, just to clarify, because somebody did ask me about virtual office hours, and I will be available, online during my office hours. I do have office hours, okay, today from 11 to 12:30, and I will be available through Zoom if anybody needs to contact me. And this is my meeting ID number 594-958-9204, and the password is 1040. All right, and I'll let this be our stopping point. And if anybody has questions, I will stick around. Otherwise, we'll pick up next time on Friday.